Okay, now let's look at an example where we solve for solubility from a known KSP. Okay, so here is an example. So this says Mercury 2 chloride has a KSP equal to 1.3 times 10 to the negative 18th. What is the solubility of mercury 2 chloride in grams per liter? Grams per liter. So first we'll write the solubility equilibrium. So the solubility equilibrium is the mercury 2 chloride solid. It's going to break apart into mercury 2 plus aqueous plus chlorine, which is 1 minus, which means for every 1 mole of this that breaks apart, 2 moles of chloride ions are going to be formed. So if you were to write the KSP, it would be the concentration of silver 2 times the concentration of the chloride ion squared. So let's write the equilibrium table. So again, here's my reaction. Again, this solid part doesn't contribute. So we don't start out with any of these ions. Now the change is plus x, so this is x. The change here is plus 2x, so this is 2x. So now the KSP equals x times 2x squared. Well, 2x squared is 4x squared times x is 4x cubed. So KSP equals 4x cubed. So we can use this because we know the KSP is given to us in the problem as 1.3 times 10 to the negative 18th. So 4x cubed equals 1.3 times 10 to the negative 18th. So now I can solve for x. We'll divide both sides by 4 and say x cubed equals 3.25 times 10 to the negative 19th. Take the cube root of both sides and find out that x equals 6.88 times 10 to the negative 7th. So remember what x is. X is the molar solubility. Remember, in moles per liter. So that means 6.88 times 10 to the negative 7th moles of mercury 2 chloride will dissolve in 1 liter of water. So now I need to know what is the molar mass of mercury 2 chloride. So if I look at the periodic table, mercury has a molar mass of 200.59 plus 2 of chlorine, which is 35.45, which is about 271 grams, 271.49 grams, sorry, 1 liter, sorry, I'm doing this wrong, 1 mole is 271.49 grams. Moles will cancel. My answer is going to be in grams per liter, which is what the question asked for. So 271.49 times 6.88 times 10 to the negative 7th is about 1 point, with two significant figures, 1.9 times 10 to the negative 4th grams per liter. So only 1.9 times 10 to the negative 4th grams of mercury 2 chloride would dissolve in 1 liter of water. So that's what that means when the KSP is 1.3 times 10 to the negative 18th. So what you need to solve this for solubility from the KSP is, once you're given the KSP, you're going to write the solubility equilibrium, see what the KSP expression is, use the equilibrium table to solve for X. X is the molar solubility in moles per liter. That's how many moles per liter would have dissolved. And then you would use the molar mass from the periodic table to solve for solubility in grams per liter.